Okay, so now we're going to write the linear equation by looking at the graph of the line. So from the graph to the linear equation. So specifically in slope-intercept form. So we're going to write the equation of this line in this form, y equals mx plus b, where this m, whatever number we put here, that's our slope. And we're going to put the number here that's the y-intercept. So those are the two pieces of information we need to take from the graph. So let's do the y-intercept first. So I'm going to write them over here and then we'll plug them in. So the slope and the y-intercept. We're looking for those two pieces of information. Remember, slope is change in y over change in x. So we just look at our line. So the definition of y-intercept is just the point where this line crosses or intercepts the y-axis. So if I look at my line, boom, right there. So this point right here is my y-intercept. So I just have to read this point. So this is, y-intercepts are always 0 for the x-axis because it's not right or left. It's right at the, like you start at the origin, go 1 up. So this is the point 0, 1. Point 0, 1. So that number is going to go right there. We'll put that there in a sec. Next, we find the slope. So to find slope, we need 2 points. We should choose points on the lattice, meaning that intersect at whole numbers here. So we'll just use the y-intercept as one of them. Then if I look carefully, I can see that this is one right there. So be careful, don't use that. You can see it's a little off, don't use that, it's a little off. Pick points that are right at the lattice. So now I'm going to draw my slope triangle. Right? So this line goes up from left to right. So I'll go up, up until I'm directly across from this point, and then I'll go over to that point. So whatever this distance is, this leg of this right triangle, this length here, that's going to be my change in y. We can see my scale is 1, right? I'm counting by ones, 1, 2, 3, 4, 5. So I'm counting by 1. So I can just count by 1. So I count from this point up until I'm right across from that point. So we can see I count up 1, 2, 3. It's going up on the y-axis, so that's positive. So my change in y is 3. And then I find my change in x, or my horizontal change between those points, change in the x-coordinates. And I go over 1, 2, 3, 4, 5, so it's positive 5. So those two numbers make up my slope. Slope is the ratio or the fraction here of change in y over change in x. My change in y is positive 3. My change in x is positive 5. So that's it. I just plug in these two numbers in the appropriate place. So the slope is the m, and the y-intercept is the b in my slope-intercept form. So the equation of this line in slope-intercept form is y equals 3/5 x. And I use the y of the y-intercept plus 1. Meaning this line should cross at 0, 1. It does. Cross the y-axis at 0, 1. And it should go up 3, right 5 from any point. So up 3, right 5, there's the next point on my line. So let's do one more example of that. So we'll tilt down to another example. Here's another line. Now we can see that this line goes down from left to right, so we would anticipate a negative slope, right, because it goes down from left to right. And again, the two pieces of information I need are my slope. In fact, I'll label them here. This is the slope. This is my y-intercept. And slope is, remember, change in y over change in x. And I need the b, or the y-intercept, which is going to be 0, comma something. Oop, we're off the graph a little bit. Let me zoom out just a touch. There we go. Okay, so let's do it. So first we do the y-intercept. Easy. Just go look at the graph, see where it crosses. Here's your y-axis. Here's your line. So just look where that line crosses the y-axis, crossing here at 4, or the coordinate 0, 4. So that's going to be my b. It's going to be 4, positive 4. If it crossed negative, you would put minus that number. So it doesn't have to be plus or plus negative. We usually just put minus. So now the slope. So here's one, we'll use 1 point. That's our y-intercept. Let's look for another good point there. Looks like right there. Remember, it has to cross exactly on the lattice, so that one does. So look very carefully, right? It's a little off there. Don't want to use that point. A little off here. So don't use points where it's a little off. So then draw our slope triangle. This time it's going down from left to right, so we should have a negative number for our change in y. So this is change in y here, and this will be our change in x here. So it goes down 1, 2, 3, 4, 5. Again, it goes down 1, 2, 3, 4, 5. So we would record negative 5 for our change in y. And I'll record that here as well, negative 5. And then change in x is the horizontal change, right, from this point to this point, right? How far does it go over? It goes over 1, 2, 3. Notice the scale, both are counting by ones, right? 1, 2. They're only labeled every 2, but this would be negative 3, negative 4. So each box is 1. So our scale is by ones. So then the change in x is 3, so that's my denominator here for my slope. So change in y over change in x. And that's it. Once you've found your slope, and once you've found your, reduce this if you can, but again we can't here. Once you've found your y-intercept and slope, you're good. So our slope goes in for m, so it's y equals mx. The m is negative 5/3, again negative down from left to right. And then our y-intercept of plus 4 or positive 4. Now remember, this y-intercept could be negative, in which case minus that number instead. And that's how you write a linear equation in slope-intercept form.